Hi everyone. We are going to learn about the basics of electrical circuits. The three basic elements in any electrical circuit are resistance, inductance and capacitance. In this session we will learn about resistance, which is denoted by symbol R, which is represented like this. First let us see what a circuit is. I am taking an example of a hot water circulating system. This is hot water circulating system in a hotel where hot water is circulated in a closed loop piping system by means of a motor M. Okay, wherever you need water, a tap will be provided. Whenever you turn on the water, you are going to get the water. There will be a master control by means of which we can stop or start the flow of water. Similarly, if you see an electric circuit, there will be a driving force, which is denoted by symbol V, which is known as the potential difference. Here it contains two terminals. One terminal is positive, another is negative. That means one terminal is positive potential with respect to other terminal. That means the negative terminal contains more number of electrons compared to the positive terminal. Similarly, there are many loads. The examples of the loads are AC, TV, fridge, washing machine, or a simple lamp used in our house. These two are connected by some wiring system, and there will be a switch to control the flow from source to the load. Whenever you turn on the switch, that means the closed loop path is formed. That means there exists a continuous path from the source to the load. The electrons from the negative terminal start flowing to the positive terminal of the source. This I am indicating by symbol E, which is nothing but electrons flow direction. The current is nothing but opposite to the flow of electron flow direction, which is indicated by symbol I. That means in any closed path, if a potential difference is applied across a load, the electrons start flowing from the negative terminal of the source to the positive terminal of the source. The current is nothing but opposite direction of flow of electrons. That means the current starts flowing from the positive terminal to the negative terminal of the source. The amount of current flown in this circuit is directly proportional to the potential difference applied across the circuit. If you apply the constant of proportionality, the resistance R is nothing but the constant of proportionality here. This is known as Ohm's law. Okay, that means resistance is nothing but voltage by current, which is indicated as units as ohm. Okay, what is 1 ohm? If you see, 1 ohm is nothing but when a 1 volt of potential difference is applied and 1 ampere of current is flown, this is nothing but 1 ohm. Okay, this is an example I am taking. If voltage and current vary, the amount of resistance may vary in that particular circuit. Depends on the equation. R is nothing but voltage potential difference applied in the circuit by current flown in the circuit. The power absorbed by the resistor is nothing but voltage into current. If you substitute V equal to IR, it will be I square R. If you substitute I as V by R, it will be V square by R. The energy, this is what we pay for as electric bill. This is the capacity to do work. It contains three components: the voltage at which we were supplied from the generating company, and the amount of current we consumed, and the duration of time that we have consumed. So if I substitute V equal to IR, it will be I square RT. Similarly, if you substitute I as V by R, it will be V square by R into time. The physically resistance depends on the nature of the material and its geometry. Resistance is directly proportional to length of the wire and inversely proportional to area of the cross section. If you use more lengthy wire, the resistance will be more. If you use less lengthy wire, the resistance will be less. If you use thicker wire, the resistance will be less. If you use thinner wire, the resistance will be more. If I apply the constant of proportionality, R equal to rho L by A. Rho is called resistivity of the material. For normal applications where we connect wire from source to load, the value of resistivity should be low. So the resistance value will be low, and so that the loss will be less and the drop of voltage will be less. The normal material used is copper. The important thing about resistance is it opposes the flow of current. It dissipates the energy in the form of heat. One of the examples is where resistance is used is for heating our water. I am taking an example. Here electric heater is placed in water tub and is connected to source. This wire used for electric heater is made of material which has very high resistivity value, so resistance will be high. Here whatever the electrical input energy given to the heater is converted into heat energy, and that heat energy is used to heat the water. This is the example where resistance is used as heating element. Similarly, I am going to give two more examples where resistance is used. All the loads are connected to some source input. Okay, whenever we switch on the load, it takes very high value of current. In order to limit the current, a small value of resistance is placed in series with the source. Okay, whenever we switch on the load, this resistance is going to limit the starting current drawn by the load. This resistance here, it is called as inrush current limiter. Another example, I am taking a circuit which has input and output. This circuit may contain some storage elements. As long as input is there, output is going to exist. Even though due to that storage elements, even though input is disconnected, the output may exist for some time, which is not desirable, which may lead to shock. Okay, so a very high value of resistance is placed across the output terminals to discharge any stored energy after the input is disconnected. This resistance is called as bleeder resistance. Its value will be very high. In the next session, we will learn about inductance and capacitance. Thank you.